Hello guys, welcome to this video on Google Bigtable, the scalable database behind the Google Big Data. In this session, we will explore what Bigtable is, how it works, and why it became the foundation for many of the Google core products like search, maps, YouTube, and analytics. So let's dive into the world of large-scale distributed database. Okay. So Google Bigtable is compressed high performance and highly scalable data storage system developed by Google. It was created to handle petabytes of structured data distributed across thousands of commodity servers. Internally, Google introduced Bigtable in 2004 and in 2006. It was publicly described in a landmark research paper by Five Chain et al. Titled Bigtable, a distributed storage system for structured data. Traditional relational database couldn't keep up the massive and semi-structured data Google data. Google was generating from web indexing or user activity. Bigtable was designed to solve these scalability challenges. Okay. As Google database grew exponentially and traditional relational database began to show serious limitations. Vertical scaling reached the physical limits, schemas were rigid, performance suffered from during massive read and write operations, and Bigtable introduced the horizontal scaling across many servers with low latency. With low latency and it uses sparse multidimensional data model optimized for high volume and low latency operations, ideal for large scale applications. And this is no. Now big table data model, flexible storage for sparse data. Let's look at the big table data, which can be thought of as a four-dimensional map. Each entry in this map identified by the rows, columns, column families, and timestamps. Well, okay, let's continue. So I said the row key is a unique identifier such as user 6456 and determines how data is distributed. Column family groups related columns and like profile and etc. Column qualifier represents specific data fields such as profile, emails, etc. And timestamps allows versioning so big data table can store multiple versions of data. This flexible model supports dynamic sparse data, meaning not all rows needs the same column, making big table ideal for web scaling. Taking master server manages metadata and tablet for assignments to table servers for balancing load and tablets subsets of data split from the table and distributed across servers for scalability. Efficient big table storage lifecycle. Big data table architecture is both distributed and fault tolerant, consisting of several key components. Several key components. Master server, sorry, sorry. and it's more distributed fault tolerance and Sam's game like master server handles metadata and tablet assignment to tablet servers for balancing loads, and then tablet servers host and server data tablets which are partitions for the last large table and subsets of data splits from the table and distributed across the server's scalability. And Chubby log service like coordinates ensures the reliable coordination configuration management across servers. Google file system provides a durable distributed file storage for Bigtable underlying data. Together, these components allow Bigtable to handle thousands of concurrent operations with fault tolerance and speed. Now, storage mechanism. Bigtable's efficiency comes from its storage architecture. Okay, based on the log structured merge tree, basically a lesson tree concept. Here, how it works: meme table, write to meme table incoming data is first stored in an in-memory memory table for fast write operations. Okay. Then commit log, every write is appended to a persistent log in GFS for durability and like flush to access table. Once the memory table reaches capacity, it is flushed to mutable as a stable files stored on a distributed Google file system. Okay. Then the compaction needed. Over time, the compaction process merges multiple as a stable to reduce read and amplification and improve access efficiency. Optimize read and write balance. This storage mechanism balances rapid writes and high read performance to support big tables, massive scale, like massive scalability basically, high availability, and then now the core advantage of the big data. First is scalability. Easily scales. Hmm, sorry. First is scalability. Easily scales horizontally. Then across thousands of servers to handle massive data loads, high availability distributed design ensures continuous operations despite node failures for reliable uptime, low latency, optimized for fast read and write access, ensuring quick data interactions, schema flexibility, supports dynamic columns without fixed schemas for adaptable data models. Automatic sharding data is automatically split across the tablets for efficient load and balancing and performance. Now the core users how to and these are the Google services basically. So first is Gmail stores user emails with efficient scalable storage enabling fast access. YouTube manages the enormous video metadata support content discovery at scale. Google Maps caches geospatial data to deliver rapid, reliable map access worldwide. With Google Analytics, it handles vast user behavior datasets powering real-time insights. Comparing Bigtable and HBase and Cassandra. So Bigtable is basically, sorry, actually 1 minute. Okay, Bigtable design inspired many open source NoSQL database that followed some popular systems include Apache HBase, a direct open source implementation built on Hadoop, Cassandra developed by Facebook, basically Apache, combining ideas from Bigtable, Table to Amazon's Dynamo, while it also Bigtable origins from Google and Apache Hadoop is for HBase and Apache for the Cassandra. Data model is wide column used in the Bigtable and also HBase uses wide column. Cassandra also uses wide column. Bigtable consistency is also strong and HBase is strong, also strong, and Cassandra is eventual, some little bit less. Scalability is high of Bigtable table. HBase is also high. Cassandra is also high. Use case large scale big data like Google's email system and other maps data. HBase also uses a Hadoop ecosystem and Cassandra is for decentralized data. Balancing Bigtable data and strengths and challenges. So it delivers the excellent performance at massive scale for big data workloads. Okay, supports seamless horizontal scaling, enabling flexible expansion, offer flexible schema and adaptable to diverse data formats, require high operational complexity to manage and maintain infrastructures, impose costly infrastructure demands for large-scale deployments, provide complex, limited support for complex queries such as lack of joins, and Google Bigtable sets the foundation for large-scale flexible NoSQL database designed to address big database challenges and fault tolerance and seamless scalability powers enormous Google services, showcasing the power distributed innovation effective handling of modern data demands in the data-driven world. Bigtable remains a critical pillar supporting innovation in big data technologies. Okay, so essential references for Bigtable and HBase is this is from which I get the resources. So, okay. Here's the summary. If we talk about the big tables, design philosophy is basically simple, scalable, fault tolerant, has shaped the evolution of modern cloud data infrastructure. Right? Thanks for watching. If you want this video informative, don't forget to like, share, and subscribe for more content on the big data technology and distributed systems. Okay, thank you so much.